Please make sure that you pause this video at any time to write down what I'm writing. Hello and welcome to Beyond the Basics, Episode 3, Fractions and Decimals and how they are connected. We're not going to go into details about fractions and decimals, just going to do a quick overview, and then one thing I'm going to show you in detail. So first of all, fractions are used in things like measurement, cooking, building, sewing. They're also used in algebra for ratios. They model division in algebra. They're used in slope, rationalizing denominators. You'll need your fraction stuff. And it also represents a division, which I already said, but that's one of the main things in algebra. You will see division as a fraction. Decimals are used in money, weight, metrics, percentages. They're also used in algebra. They're mainly used to represent things like irrational numbers, sine, cosine, tangents. All of those are in decimal form. They are made up of digits with a decimal point that separates the whole numbers from the pieces. The pieces can be written as a fraction over 10 or 100 or 1,000 or more. So long as it is a terminating decimal, you can turn it into a fraction that way. Decimals that repeat, you can't do it that way because they never end, so you never know what number to put them over. But I am going to teach you how to turn them back into a fraction using some algebra. All right, so notebooks ready. First thing is a quick review of fraction parts. You have the numerator, which tells you the number of pieces. You have the denominator, which tells you the size of the pieces. And then occasionally you'll have a whole number, and when fractions are bigger than 1, then you will have a whole number. Every mixed number also has an improper fraction that it's equivalent to. Now, fractions is division, such as 1/4. So you know it to be a fourth of something, but it is also 1 divided by 4. So as you can see in the little division house here, I put the 1 on the inside and the 4 on the outside. That's where it gets a little tricky because you have to divide 4 into 1. Don't worry, we've got the tools to do it. So the top number goes into the division house, the bottom number goes on the outside. First you do 4 into 1, and 4 does not go into 1. So you put a 0 over the 1 and a decimal next to that 0, and then you annex your 0, just like in regular long division. And now you continue. 4 goes into 10 twice. 2 times 4 is 8. You subtract and get 2. And then you annex another 0, and you go 4 into 20. 4 goes into 25 times. And then that's it, you're done, because you now have a 0 for the remainder. So therefore, 1/4 is the same as 0.25 as a decimal. So how do you turn a decimal back into a fraction? That's a good question. It has to do with place value. And the first place value that all other place values are based on is the ones place. There is only one ones place. All the others mirror each other, so you'll have the tens and the tenths, and the hundreds and the hundredths. But there is only one ones place. There is no oneths place. Once upon a time. No, there's only one ones place. 10 ones make a 10, so that's why that's the second decimal place is called the tens place. 100 ones makes the 100s place, so when you have a 1 in the 100s place, you have 100 ones. And then when you go smaller than the decimal, so if you're going to the right of the decimal, a 1 in the decimal place that's to the right of the decimal is the tenths place. So it would take 10 of those ones to make a whole 1. So it is 1/10. So you can see it kind of mirrors tens and 1/10. Second decimal place to the right of the decimal is called the hundredths place because it would take 100 of those to make a 1. Okay, so to use this decimal idea, 0.3 for instance. So you've got 0.3, it's in the tenths place. It's basically 3/10. So I put the 3 on top and the 10 on bottom, and you have 3/10. Doesn't simplify, so it's all done. The next one there, 3.5. Well, the 0.5 is the part that's the bits and pieces. 3 is a whole number, and as a fraction, 3 is 3. As a fraction, 0.5 is not 5 or anything like that. So you start by the same method we did with the 0.3. 5 is in the tenths place, so it's 5/10. So you could say 3 and 5/10, but it simplifies. 5/10 is the same thing as a half, so it's the same thing as 3 1/2. What about repeating decimals? I know that's what you're asking. If you haven't ever seen this, this is interesting. You're going to divide 3 into 1. And when you divide 3 into 1, 3 does not go into 1, so you put a 0, and then a decimal, and then a 0. And then you say, okay, 3 into 10, just like we did with the 1/4 earlier. 3 goes into 10 3 times. So I put a 3 up top. 3 times 3 is 9. I subtract, I get 1. And then I annex my 0, and I'm dividing into 10 again. And as soon as I divide into 10 again, that's when my decimal repeats. So I now know that this decimal is going to be a repeating decimal. There will be no end to it. It just keeps going on and on and on. And so that's why we use the 0.3 with the line over the top. And the line over the top is called the repeating bar or repeater bar or bar notation. And it simply says that whatever number is underneath it is going to repeat forever and ever and ever in that decimal. Okay, so how do you turn a repeating decimal back into a fraction? Well, 0.3, for instance, we already know it's a third, so now I'm going to show you how you go from the repeating decimal back into a fraction. And this is the part I told you about that we're going to spend a little bit more time on. First of all, is the 0.3 in the tenths place? There's a bar over top of it. Does it end at the tenths place? So in your terminating decimals, you always go with the decimal place that it ends at. 0.3 repeating does not end. So there is no number that I can put it over. And I can't put it over 10 because it doesn't end at the tenths place. So we got to figure out what to do. So here's where algebra comes in handy. What we're going to do in this video is we're going to let n stand for 0.3. Just bear with me for a minute. You'll see why. But I need 0.3 to have an equation. So I'm going to have the n on one side and the 0.3 on the other side. Now what I need to do is get rid of that repeating part of the decimal. So I'm going to multiply both sides of the n equals 0.3 repeating. I'm going to multiply both of those sides by 10. And what that's going to do is take the 0.3 repeating and bump the decimal over once. So it becomes 3.3 repeating. So when I do n times 10, I get 10n. When I do 0.3 repeating times 10, I get 3.3 repeating. Now what we're going to do is a little subtraction. And you can do these sorts of things with equations so long as you do the same thing to both sides of the equation, because then it's still equal. If you do something on one side of the equation and you don't do the same thing on the other side of the equation, then it's no longer equal. What I did here is I multiplied the left side by 10 and I multiplied the right side by 10. Now I'm going to take the 10n equation and I'm going to subtract from it the n equation. So 10n equals 3.3 repeating, subtracted by, or n equals 0.3 repeating subtracted from it. You line up your equal signs and you subtract what's on each side of the equal sign. So I'm going to take 10n and subtract n. If I have 10 n's and I subtract 1 n, I'm going to be left with 9 n's. Now on the other side, here's why we did the 10n. If I subtract 0.3 repeating from 3.3 repeating, what happens to the repeating part of the decimal? 3 minus 0 is 3. 0.3 repeating minus 0.3 repeating cancels out. It's gone. The problematic part of the decimal is now gone. Okay, so I subtracted it out. Now I simply divide both sides by 9 to solve this simple equation. And 3 over 9 simplifies to 1/3. Just like you wrote above, 1/3 is equal to 0.3 repeating. This is how you go from a repeating decimal back into a fraction. And I know what you're thinking. You're thinking, but what if more than one number repeats? Like 0.27 repeating. So if it's 0.27, 27, 27, 27, 27, 27, 27, and it goes on and on and on and on forever. How do we do that one? Very similar. So we start again with our n statement. So we have n equals 0.27 repeating. And then instead of doing 10 times on both sides, I'm going to do 100 times on both sides. Since the 2 and the 7 are repeating, I need the 2 and the 7 to go to the left side of the decimal so that I can subtract off the repeating part of the decimal and still have something remaining. So I start with 100n equals 27.27 repeating. Then I subtract n equals 0.27. You might notice I've made a little mistake. I put 27.27 twice. I will correct it here in just a moment on that video. So 100n minus 1n is 99n. And here's where I notice, oh, and erase it. It is actually 0.27. My apologies. Hope that did not confuse you. So now we're going to subtract the 0.27 repeating, and that cancels off the repeating part of the decimal, leaving just 27. Now you divide by 99 on both sides, and you have n equals 27 over 99. And then you simplify that. Well, those are both divisible by 3. Oh, they're also both divisible by 9. And you end up with 3/11. I know what you're thinking, but what if some of the numbers behind the decimal don't repeat, but others do, like in 0.16 repeating? That's a great question. You start out the same way we did before. You have your n statement, so I'm going to have n equals 0.616 repeating, and only the 6 is repeating. I'm going to have to do 3 n statements this time, because I'm going to need to have the 0.6 repeating part. The 6 repeating parts part I need to subtract off. So the first thing I do is multiply both sides of that statement by 10, because that leaves the 0.6 repeating all by itself on its side of the decimal. But I also need the 6 on the other side of the decimal to make my proper fraction. So I'm also going to multiply the original n statement by 100. So you have 100n equals 16.6 repeating. And those last two statements are what I'm going to use to turn this back into a fraction. So you start with 100n equals 16.6 repeating, and then you're going to subtract from it 10n minus 1.6 repeating. As you can see from that, the 0.6 repeating is going to cancel. So once I subtract, it's going to end up all right. But I have 100 minus 10 this time, so it's 90n equals, and then the 0.6 repeating cancels. Now I have 16 minus 1, which is 15. Again, you solve for n, so it's going to be dividing by 90 on both sides. So n equals 15 over 90, and 15 goes into 90. So 15 goes into 15 once, and 15 goes into 96 times, because 0.16 repeating is equal to 1/6. And now here's some examples in practice. Pause it, write them down, give them a try. I am going to do number 1 as an example here. So turning 1/2 into a decimal. You're going to put the 2 on the outside, the 1 on the inside, and 2 does not go into 1. So you add a 0, and you keep going. So now you take some time to practice those 10 practice problems. Come back here, and I will have the answer. So pause this, and then the answers are on the next slide, so you can check your work. And then there are solutions to follow if you need solutions. I hope everything goes well. Thanks for watching.